But you're right, it is A. I kind of lived to be rude. Alright, why is it A? The dot product is 0, that's correct. 2 times 1 is 2. 1 times negative, dang it. 1 times negative 2 is negative 2. So the dot product is 0. Anytime you get a 0 dot product, right, they're orthogonal. Now, there is no way to tell straight from the dot product if it's parallel. So tomorrow, if you get a dot product that's not 0, to see if it's parallel, you're going to find the angle between those two vectors. If that angle is 0 or 180, they're parallel. If it is 0 or 180, then they're parallel. Anything else, and it'll be neither. And we're going to do an angle between the vectors problem a little later in case you're wondering, or in case you've forgotten since yesterday, how we do that. Yeah. That's right. The angle will be 0 or 180 if it is parallel. Questions on this one? Well, that was one of the review problems right there. I believe that was actually number 2. So, here we go. Number 1. Find the area of the triangle having the given measurements. We've only dealt with area in one section, and there's only one formula that we used for it. The 1/2 whatever. Well, of course I know it, but do you know it? Sine. Yeah. That's right. Now, the only reason we change up the letters, just remember that the angle, well, it doesn't matter. It'll give you the literally bare amount of information. So just plug the side lengths in for the sides and the angle in for the angle. And don't really overthink it for right now. So just punch that in. You need to make sure you're in degree mode. We're going to be bouncing back and forth all day today, but this one has degrees in the problem, so you need to be in degree mode. What did you ask, Tyler? Yeah, basically, yeah, just side angle. 1/2 side. Yes, sir. Which rounds to 16. That's right. Absolutely. This practice test is also available in a paper copy online, in case you're interested. But for what you use tomorrow, it has to be handwritten. What? Yeah, square yards. All right. Does anybody need me to leave this up there for a moment? Choppity chop, chop, chop. Got 19 questions. Get going. I'm just saying, don't spend the first 5 minutes staring and then writing like crazy after. As soon as I flip, you write. Now we have so much to do today, I feel like that would just be a distraction. Otherwise it would. What? It's true. Hey, chatty teddies. A little less conversation. Even if you're not writing, it's distracting. No wonder why I chose Teddy. Teddy Natties. Dang it. We know math. Botched it. Okay, next problem. Solve the triangle. Round lengths to the nearest tenth. See, it was 16 yards. There's going to be 3 of these solve the triangle problems. And you're going to have to figure out which formula to use, sines or cosines, or SOHCAHTOA. But you only use SOHCAHTOA if it's a right triangle, which you can pretty much assume all these are not going to be unless it says so. So, you tell me. Wrong. Why is it law of cosines and not sines? Yes, my exact phraseology. There is no pair. There is no AA, BB, or CC. Unless you have a pair, AA, like side A and angle A, you can't use law of sines because it's all built around a proportion. So you have to use law of cosines. So for us, that'd be little a squared. It's always the side opposite your angle you isolate. equals b squared plus c squared minus 2bc cosine big fat A. So, a squared equals 7 squared plus 11 squared minus 2 times 7 times 11. Cosine of 1.7. My board's messing up again. Josh, we've been having such a good run lately. You know that's the board. Oh, yeah, it's been working lately. Apparently it heard me bad-mouthing it sometime recently. Remember, you cannot subtract the numbers. You have to do the multiplication, then subtract. Yes, you could. And then take the square root of it. 0.2. Before that, isn't it like 262 or something like that? 262.6. Take the square root, and you get 16.2. And option B is the only one with 16.2. But, Joseph, if another one had 16.2, how would we then start to solve the rest of the problem? I'm sorry? That's right. And what would we use to do that? Right, law of sines. Yeah. Yes, sir. Yes, it is. So we're going to be doing some law of sines a little later, so I'm not going to bother to keep going with that one. But again, if another answer had 16.2 as answer A, you would then need to use law of sines to find angles B or C. So for this problem, after we get that, if that was not definitive, yes. But as it was the only one with 16.2, so we just stopped. I've come to find out from the last class, there's a lot of process elimination you can do on this test if you know where to put your mind. If that makes any sense. Okay. Yes, although I doubt they'll make that kind of obvious mistake. It'll be something more like, well, you'll see when we get there. Okay, same exact directions, but new set of things to work with. What formula are we going to use for this one? That's right, you still have to use law of cosine. You don't have no stinking angle. Which one are we going to look for first? That's right, A. What am I doing? Actually, no, I had a complete brain freeze. I just saw A and wrote it. What? Same direction? Yeah, you're just solving for everything you don't know. Once again, come on. Once again, you can't not subtract these numbers too early. I think. No. No. Otherwise this would have been right. No, I did this last question. And then you take cosine inverse. Yes. Excuse me? 30 even? So which one is that? I reckon that'd be C. Of that fraction. Yes, sir. Now, even if that angle matched another angle, you'd then use the law of sine to find the second smallest angle and keep going. But as soon as you find an answer that's unique, you can just stop. This is not one you could have logicked your way out of any answers. You just had to work it. Questions about something on this slide? Nay? No questions? Let's just skip on ahead, like Peter Rabbit in the Briar Patch. So impressed that you knew that. Okay, here we go. Now, how are we going to solve this one? Mr. Rhodes. That's exactly what we will do, and you would find the third. Now what are you going to do to solve it? You're all over it. Right, law of sines. Excuse me? What has to be C? Why? You're right. This is one you could logic your way through. We'll talk about that in a second. You are exactly correct, though. Couldn't be more correct. Well, you could. It'd be hard. Good. While they're right, we'll let people write. Then we'll talk about it. Would you like to come up here and use my pointy fingers? Oh, yeah. Keep this away, sir. When you're done writing, Coach is going to give a presentation about how you can think your way through this problem. Now, it's not a guarantee you can do it tomorrow, but this one you should have. All people are writing? Go.
Okay, we just like eliminate take those two angles stretch together.
These out.
Next thing we're going to do is notice that those two angles are less than 90. That this angle is bigger than 90, so therefore it's got to be the head of the biggest side. Therefore,
has to be the biggest.
Therefore, A and B cannot be 25. So that means that out. Now you look at A, which is the smallest angle.
So you said A is out because B has to be the biggest side, and the answer was option A would be the biggest side, which is that.
Yeah.
Okay. So it's down to B and C.
And then now you look at which angle is smallest. That whatever angle is smallest means that side can be. So this one would be A is the smallest angle, but that's the biggest side. Therefore, that's the right.
Wicked smart. You're wicked smart. That's exactly right. And the answer is C. Of course, again, even if you didn't notice that, no big deal. Continue to work the law of sines, and you would have found that A is 11.2, hopefully. If you did not get that A was 11.2, if you like, we can take a look at your calculator. Maybe we're punching something in wrong. Is anybody getting something other than C when you work this? Oh, yeah. Sure. Well, do you get where we got the original formula right here? So you cross multiply. Well, as soon as it's done thinking. 25 times sine 26 equals A times sine 103. So then you divide by sine 103 to solve for A. And then when you punch this whole thing in the calculator, you should get 11.2. Let's see. So, too far. I'm going to have to cover this up for a second. So, 25 times sine 26. You should still be in degree mode. and then divide that by sine 103, 11.2. We good? All right. Good. Impressive thinking. Number 6. Use the given vectors to find the specified scalar. Even if you don't know what a scalar is, doesn't matter. Basically, just do what it says below. Find u times w and then add that to v times w. Just find some dot products. This is what we did yesterday when all our trouble seemed so far away. Yes. Now it looks like they're here to stay. I'm done. I promise. So u dot w add them two together, and you should get C. Does anybody have a question? Well, you're writing. That's cool. But when you're done writing, if you want to take a look at that and do some thinking, if you have a question about where anything on that board came from, please ask and I can elaborate. Yes, sir. Yep. That'd be correct. Other questions? All right. Making good time. I will warn you that the second half of this review takes longer than the first. So we can't dawdle. No. That's correct. That is big time correct. That could not be more correct. My sofa. Where are you going? You in a band? What do you play, Josh? You a bass drummist, or are you like one of those little bitty drummers? Does it hang off your stomach like a really big baby? And you just pound it on the sides? Obviously, the simile stopped with the way you carry it. Not meaning you should pound a baby on the sides, obviously. Although that little jerk's kicking on you. Shut up. I'm sorry. I would never do that. I would not do that. I'd be one of those. I'll probably be one of those dads one day that like talk like little kid language to a tummy, even though they probably can't hear me. The Guja big boy. Okay. Are there any questions about anything that's on the board? What? Well, obviously, if it's a girl, I won't say boy, and I'll have to change my tone. If he does, I'll be proud of him, and I might name him Brayton. Okay, if he smacks me. Okay, anyway. Name the amplitude or period as requested. I just did a twofer in this slide. We just switched, so you didn't miss anything. This was the first question that the last class had a lot of questions about. And there's our first. Well, I'll tell you. First, let's do the amplitude. Tyler, what do you think the amplitude of number 8 is? Yes. 4. You're correct. It's just the number in the front. Now, it didn't ask this, but what would the amplitude of 7 have been? It'd be just positive 1/5. There isn't an amplitude. You won't have a negative amplitude. So tomorrow, if they had given us, let's say it had asked us for the amplitude, and if it had said negative 1/5 and positive 1/5, remember to take positive. Amplitude's easy. Period. Who can tell me how you find the period? 2 pi over b. That's correct. Your b value is the number being multiplied by your theta, or in this case, your x. What is being multiplied by x here? That's right. There's no number, so it's just 1. So 2 pi over 1 gives you 2 pi. So the period is 2 pi. We're also going to do a phase shift and a vertical shift problem. You don't multiply. It's 2 pi over b. End of story. Number being multiplied by your x or theta. So like say this one had been negative 1/5 sine of 4x, it'd be 2 pi over 4. And that would give you your period. One thing I don't like that they do here is that they only, I wish they had just given one big equation so you'd be used to seeing it all. Like for instance, in fact I'm just going to take a step aside and we're going to do that right now. Rather than do the other 2 questions later, phase shift and period, we're just going to look at it all at once real quick. And we'll just skip those problems when we get to it. Let's say it gave us, I'll just choose cosine instead of sine for whatever reason. Let's say it's a negative 2/3 cosine 2 theta minus pi over 3 plus 2. First off, one at a time. Mr. Hale, what's my amplitude? 2/3. Very good. Emily, what's my period going to be? Pi. Very good. Who can tell me how I'm going to find my phase shift? It's C over B. That's right. C, now remember, you always take the opposite of the sign. So positive pi over 3 over 2. Now, a lot of people have trouble dividing fractions. Whenever you divide something by 2, are you making it bigger or smaller? You're making it smaller. So basically just double the denominator. So that's going to be pi over 6. Pi over 6 would be your phase shift. Now tomorrow, it's not going to just say plus pi over 6, negative pi over 6, plus this, minus this. It's just going to say, you might have 2 options. One says pi over 6 units to the left, pi over 6 units to the right. If it's positive when you're done, it's to the right. If it's negative, it's to the left. So maybe we will, that's a phase shift question later. C over B. Always take the opposite of this sign. Up to. You got it. Up to. It's just the number at the end. In this case, up to. Very impressive so far. Any questions about something we just discussed? We are going to look at another phase shift problem later. But this is your last chance to ask about amplitude, period, or vertical shift. It was 2 pi over 2, which was 1 pi. It is exciting. For number, well, that's a good question. See, this is why I didn't like the way they did this. Technically, they didn't add anything, so your C value would just be 0. So 0 over 1. If there's no C, there's no phase shift. So it would just be nothing. No phase shift. See everybody? Yep. Yeah. If you notice on your calculator, your variable button is like x, comma, theta, comma, t. That's just your random variable. So they're all interchangeable. All the same. C over B. Yeah, this is your C value. This is your B value. Just remember, your C, you will always take the opposite sign. So this one was negative, so we take it positive up here. If it had been a plus pi over 3, then it would have been negative pi over 3 over 2. Okay, moving on. Number 9. Now, please notice the direction. Well, I'll give you a second to write first. Write, and then we'll talk about it. Yep. Those exact directions for like 3 different problems. We're going to discuss that in just a second. Anybody who wants to go ahead and write, I don't want them to have to multitask because this is kind of this is the one we need to discuss. Okay. No. Well, there are 2 of this exact kind of problem, but they have the same direction. The key in the directions is the SSA. If you see the SSA, this is what it wants you to do. Because that's getting us to think of the ambiguous case. That thing where we had to do the tests and everything. Alright. Hopefully, somewhere in your notes, you've got those tests that we had to do for the ambiguous case of the law of signs. And those tests were, the first step. Who can tell me what the first step was? Figuring how many solutions we have. Acute or obtuse. Very good. So, are we acute or obtuse? We're acute. So then we go to that. Next thing we check for is what? Well, in this case, there's no A. So which side are we looking at? B. We're looking at the side opposite the angle. Is this side the bigger side? No. So now we have to do that test. If it had been the bigger, or even the same, we could have just said one solution, and we would have started solving for it. But instead, we have to compare it. Is 2 less than, greater than, or equal to the other side times sine of the angle? That was the test. Sure. 3 sine 70. Before you even tell me what it is, you need to remember that stands for the shortest distance it can be. So if this is less than this, no solution. If it's greater than this, we're going to have 2 solutions, and if they are equal, we'll have exactly 1 solution. So here's the thing. If they're equal, we'll have 1 solution. But if they're not, unless this perfectly equals 2, it's going to have to be C, because two triangles isn't even an option up here. They didn't give us a 2 solution possible answer. So, what is 3 sine 70? 1.8? 2.8. This is less than this, which means it's not long enough, therefore, no solution. Well, and the only chance, that you'd be wrong is if 3 sine 70 happened to be perfectly equal. Unless, did you have another piece of logic you were meaning? Oh yeah, there's no 90 degrees in the answer. Okay. Dude, your brain is aggressive. That is so true. Nobody mentioned that, and I never knew that. That's true. Well, that's a little more obvious. They give you another piece. That's obviously done. Very good. Very good. So there's nothing to do on this one. Of course, another thing we could have done, if these 2 had equal. If this had equaled and been 1 solution, it would have been a right triangle. And there is no right angle, so that's another way you could have assumed there's no triangle. I think it was just the case test. I don't think we had a specific name for it. All right, next question. Very similar, except not quite as obvious. It's an SSA. We have to find how many solutions it has, and then based on that, we'll have to solve for those solutions. Now, obviously, if it has 0 or 2 solutions, the answer will kind of be right in front of us. So we do our test. All of you right. Well, the directions are the same. I hope you're not writing the directions all over. They're literally the exact same. Obtuse or acute? Acute. Is my side the biggest side? No, so I have to do the test again. So, let's do it. 6.37 sine 13. Somebody tell me what it is. 1.4. Is our side bigger than or less than that? I guess it could have been. Bigger. That's right. So it's two solutions. So we can immediately assume the answer is A. Now, tomorrow, I'm going to tell you this right now. You do have one of the problems you have like this is a two-solution answer, but there are multiple options that are two solutions. So we're going to go ahead and work this as if that wasn't conclusive. We did the exact same thing we did on the last one. No. 6.37 sine 13. The one you don't use is the side opposite triangle. And they saw that it was smaller, therefore we have two solutions. So, that means we need to solve for A, C, and C twice. Big A, big C, and little c. First thing you're going to do is just start out looking for A. Well, yes. But tomorrow you're going to have multiple answers that are two solutions. So I'm showing you how you would work that. So, I did. It keeps moving. Somebody keeps moving here. Just start away, I guess. Sorry. I know. Anyway, so here we go. Law of sine. Sine 13 over 4.3 equals sine of A over 6.37. Solving it just the way we did the last few. Cross multiply. Divide by 4.3. Then take sine inverse. Somebody take sine inverse of that big old fraction. Well, I guess the answer is going to be, yeah, 19. Now, tomorrow, how do you find, there's two ways. You can either go ahead and just finish that triangle and then go to the other one. Let's just do that first. What's my angle C going to be? How am I going to find my angle C? Yeah, you add 1913, subtract it from 180, and that gives you 148. And then you just do law of sines again to find side C. Now I'm trusting you can do that because we've done it a half dozen times in this review alone. But you just do law of sines again and get side C. Now, how am I going to find my other angle A other than just looking at the board? That's right. It's going to be supplementary to this one. Whatever the first angle you found was, the supplement to that will be your other one. So 161. You cannot do the same thing for angle C. You have to then take A, add it to B, subtract from 180, and you get 6. 161 plus 13 minus 180 is 6. And then once again, you'll do law of sines again and get your other side C. But surely by then, you'll be able to just pick out the answer anyway. The second triangle. Once you find your first angle, the other angle A will be the supplement to that. So you just subtract it from 180. Yeah. Yes. This one you didn't have to do all this, but you will have to tomorrow. Questions? And of course, if it would have been an obtuse angle, it's either one solution or no solution. So just those are the even easier scenarios. Questions? That's fine. I believe this is the last one of these. Yeah. Now, I'll tell you this tomorrow before you get too stressed. This one's a tad harder than the one that's going to be on your test tomorrow, but there will still be a two-part question like this. So I'll let you write it down, draw what you need to draw, and then we'll work it. While we're writing, if somebody wants to volunteer to try to explain how we're going to solve this. Here. 70. Where's 70 coming from? Actually, and I can see why you would think that. This isn't 50. The whole thing is 50, and this little piece is 13. And the way you're supposed to have noticed that is by the loop. This entire loop goes with the 50. This loop goes with 37. Yeah. Well, you could still go ahead and do that same logic to find these missing angles. You could also do the same thing down here to find that this is 53. In fact, you're going to need to do that. But as far as solving for A, obviously our first instinct is law of sines. But what's the problem? We don't have a side link on that top triangle to use law of sines. So how can we find one? We do have a side link somewhere here. Yeah, but how can we make that help? How can we get that to give us something for the triangle that we're actually looking for? That's right. The hypotenuse is a common side. If we can solve for this, then we'll have a side on this triangle and we can do the law of sines. 90 plus 50 minus 180. So, there's multiple ways you can solve for that hypotenuse x. What's one of them? Law of sines, basically. So sine 53 over 51 equals sine 90 over x. However, anytime you have a right triangle, you also have the option of using SOHCAHTOA. We're given 51, we're given 37, we're looking for the hypotenuse, that's cosine. Cosine 37 equals adjacent over hypotenuse. Both of them will work the exact same. Yes, law of sines. I don't care which one you do, but somebody do that and let me know what you get for x. 60, so approximately 64. Alright, so we're going to plug that in for x. Now I have enough to do law of sines with my top triangle. Can somebody tell me how I'm going to do that? What the setup would be? Equals, again, 13. Yeah. I cannot stress enough how important, well, how much I would encourage you to show your work tomorrow. For instance, let's say you did this whole problem, but instead of putting in 13, you put in 50. Now your answer is wrong. You show this work, that's 4 out of 5 points right there. There's another question coming up soon that I missed in my last class just because I punched it in the calculator wrong. But again, if I had shown the work that I put on the board, 4 out of 5 at minimum. You're looking for this, right? So your first instinct would have been just done the law of sines up here to solve for A. But the problem is, we don't have a side link to use with the law of sines. So we needed one. So we had to find this piece, which is why we did this blue stuff and found it. Then we did this, and what was the answer? All right, good job. There will be a 2-part problem on tomorrow's test. Questions on this one? Excuse me? Oh, yeah. You mean other than everything that I've shown? Subtract. That's true. You could have looked at it. If you don't like law of sines, you could have found this entire length using the big triangle, very good, and the 50 degrees, and then you could have found this length doing what we already did, and then just subtract it. Yeah, very good. Didn't even think of that. Very, very good. Okay. Number 12, polar coordinates. Best way to do this one's the finger test. 4 takes you to C. Pi over 2 is where? Up. Now, negative degree, negative angle flips you over the x-axis, and then what does the negative radius do? Flips you over the origin, which just so happens to be the exact same flip, and takes you back to point A. I hate the way the book does this. I wish it was option A is A, option B is B, because I think answer's A, and I think A, but that's actually wrong. Because A is point B. You actually want to pick B, which is point A. I don't know why they do that. Yeah, that is easy. So, please pay attention to that tomorrow. And don't think A, and just hit A. Look for option A. Now, we're going to look at one or two more of these because, you mean what they do to it?
Yeah.
We're going to talk about, I'm going to do it, let's do another one because it's a little harder to visualize on that one because it looks like they're the same flips, but they're not normally. Let's do another double negative. Okay. Up. There we go. So, let's say this has been our problem. 2 units, 7 pi over 6 in which quadrant? Third. Takes us here. So, the negative angle flips you over the x-axis to here. Always over the x-axis. The negative radius flips you over the origin to here. So you would have picked a point that was there. And tomorrow you might not have both of them negative. You might only have one of them negative, which would be even better. Just remember, negative angle flips you over the x-axis. Negative radius flips you over the origin, directly opposite of where you are. The one that was on the original? C. The origin and the negative angle flips you over the x-axis. Now somebody astutely pointed out last class, couldn't you just take both of things literally? Well, yeah, you could. Remember, a negative radian just travels clockwise, right? They thought it was easier just to go, instead of positive 4, go out negative 4, and instead of traveling positive pi over 2 from there, just travel negative pi over 2, which does take you to A. And you're welcome to do it like that if you want to read it like that. But I find, I don't know, in the past, people have preferred the way I've taught it. So, but yes, you could just come out to your negative radius and then travel however many degrees at once in the proper direction. That would take you to the point as well. Questions about something from this page? Maybe a what if? You could, sure, or yeah, you could. So if you had, that'd have been negative 4, negative 90. So you come out negative 4 and travel negative 90 degrees, and it would have taken you to point A as well. Any questions? No, denominator, nothing to do with it. The radius. Over the origin. Directly opposite of wherever it is. The angle. Or down, depending on where it is. Yeah. Okay. Alright, now this is potentially the most... Actually, you know what? We're going to come back to this one, and I'll show you why in just a second. We're going to come back to it. We're going to do this one first. It gives us a polar coordinate, and it wants us to find the rectangular coordinates. Does anybody have the formula for that? It's our cosine theta for the x and our sine theta for the y. Now, if you punch these into your calculator, it's going to give you a decimal, which is fine. You could just equate that decimal back to radical 3 over 2. Or, an even easier way to do it, who has a unit circle in front of them? Josh, what is cosine 3 pi over 4? Is it negative radical 2 over 2? Okay, so radius times cosine 3 pi over 4. Multiply those and you get positive 3 radical 2 over 2, which is either B or D. What is sine of 3 pi over 4? Just positive. So negative 3 times positive radical 2 over 2 would be negative radical 3 radical 2 over 2, which would be b. Right, x, y. If you want to avoid decimals, now decimals aren't bad, you just might have to work backwards to find out what that would be by punching these in the calculator. But yeah, the easier way to do those is just use the unit circle, and the answer would be B. Now, the reason we skipped that one and came back to this. Yes, I forgot to write the 3. I had to squeeze it in there. The question that we had was, well, let me just put it up there. Oh, that was it. Now, the question we had is very similar. It says, here's a vector with a magnitude of 8 and an angle of 30 degrees. That is so much like the polar coordinates question we just did. But instead of it saying, what's this rectangular coordinate, it's saying, what is this equation? But it's pretty much the exact same question. Essentially, you're still doing, but instead of r cosine theta equaling your x, r, which is basically your magnitude here, is now going to equal your I value. And r sine theta will equal your y value, or your j. So let's do it the same way. Magnitude is 8. Who else has a unit circle? Caitlin. What is cosine 30 degrees? Radical 3 over 2. So I multiply. 8 radical 3 over 2 reduces to what? 4 radical 3? So positive 4 radical 3 is my I value. Which one is it? A. Let's do the second part. R, I know we know what the answer is now, but R is 8. What is sine of 30 degrees on your unit circle? 1/2. 8 times 1/2 is 4. So that is your J value, 4J. Yeah, this is your I, this is your J. That is the easiest way to do this, by using the unit circle. You're more than welcome to punch it in the calculator, but you're going to get something like 2.76, and you have to punch these in and see which one equals that, which you can do, but it's probably a little hard, because you have to do an extra step. Using the unit circle will help you with these. Are there questions about where any of this is coming from? Get up, bird. All right. Would anybody like me to re-explain anything that's up here? Okay, well that's good. That went much smoother than it did last time. All right, this one, yeah, that's just the opposite. It says here's your rectangular coordinates, find your polar. So you can't use that formula. Please note the difference somewhere in your notes. When you start with rectangular, you do not use that formula. It's only when you start with polar. Now I'm going to graph this one, but you don't have to graph it tomorrow. I just want you to help you visualize it. If you were, wow, that's really horrible. If you were to graph this, so your x is 5 radical 3, your y is 5. That means if you were to make an angle out of this, like that's your vector, right? Your I component would be 5 radical 3, and your j component would be 5. How can you find the magnitude? Oh, I'm sorry, this isn't. How can you find the radius, I guess it is, since we're in polar? What? Yeah, Pythagorean theorem. A squared plus b squared equals your radius squared. So that's 25 times 3 is 75, plus 25 equals r squared. And what's my radius? 10. So it has to be A or C. 5 squared is still 25, but you're right about this. So 25 times that 3. Yeah. And I'll tell you how to find the angle in just a second. Go ahead and first write that down. Make sure you know how to find the radius. polar coordinates. You may have. There's a. I don't remember. Yes. There's a lesson about it online if that would help. That's great. Okay. Now, to find the angle, there's multiple ways you can do it. The easiest way is to use SOHCAHTOA. Easiest way. Because think about it like this. The y value will always be your opposite, and the x value will always be your adjacent. So you'll always, to find your angle, be using tangent. Tangent of theta, which is what we're looking for, is theta. Tangent of theta would be 5 over 5 radical 3, and you just need to take tan inverse. What mode do I need to be in? Radian. Yeah, I know what you meant. Radian. You need to be in radian. Now, this is the one I missed last class because I punched in the calculator wrong. If you punch in, let me make sure I'm in radian first. Actually, it's probably easiest if you convert those to degrees because this is going to give you a decimal, but that's completely up to you. Now, it tells me 1.04, approximately 1.05, which is pi over 3. That is wrong. Why is it wrong? Somebody look at the calculator and tell me why it's giving me the wrong answer. Because the answer is A, pi over 6, not pi over 3. That's right. It's doing, I didn't catch this last class. Somebody had to tell me. I was just sure the answer key was wrong. The calculator is doing 5 divided by 5 times radical 3. But it's actually, what? That's correct. That's pi over 6. That's the correct answer. You want to put the entire denominator in parentheses, which is pi over 6, which is correct. Now, if you're wondering how on earth are you getting pi over 6 as that, you can just punch using the calculator. Pi over 6 equals, and you'll get that same decimal. And that might be the easier way to do it. So the answer is A. Now, if you want a quicker, in your notes, if you want a quick way to do this problem without having to draw or think about everything, just remember this. A squared plus B squared will always be your radius squared. And if you just want to think of a quick way to find your angle every time, you'll always just do tan inverse of your y divided by your x. To find your angle, if you're given rectangular, you'll just take tan inverse of your y over your x every time. I wish your calculator, I'm surprised calculators don't give answers in terms of pi. With all the other things they can do, invent a calculator. I don't care quite that much. Which part? The quick way? Okay, essentially, when you're doing this problem tomorrow, it's essentially giving you an x and a y, right? A quick way to do it, this right here will solve for your radius, and this will solve for your angle. Assuming, it's just going to give you some point x, y, and given those points, that is the shortcut to finding the two things that you need. Your radius, r, and your angle, theta. Yes. R theta. Whoa. That hurt. It did. No betting necessary. I think that's what it's like to croak. I hope not. No, I mean like a frog. Maybe they just have really big, whatever that was. What is that? I don't even know. It's like my breath is... What? Trucks? Oh. I don't know. I don't hang out too many drunks. I'll have to start spiking my wife's sweet tea from McDonald's and I'll find out. This tastes different, but I like it. Okay. Oh, God. Not doing that again. Okay. We already did 15. That's good. Saving time. 16. Find the angle between. This was straight from yesterday. I hope. And I know you probably have this formula in your notes, but to save time, here was the formula. Dot product divided by the product of the magnitudes. So you just need to find your magnitudes and your dot product and plug them in. What's my dot going to be? What's my dot going to be? It is going to be -1. That's true. And what my mag's going to be? Well, I guess it's U and V, not C and W. I need my mags, peeps. No. Yeah, 1 squared plus 1 squared, square root 2. What about these? I reckon that's right. That's what I'm getting as well. Right. So, ready for the calculator. Now you're going to need to be in degree mode. Having to jump back and forth. Degree mode. Because the answers are in degrees. So, cosine inverse. No, and I know why you're asking, and I think that's in bad taste. Steve Irwin, where art thou? Yeah, it wasn't because of the accent. No. The Stingray was freaked out because he was Australian. Most of the marine biologists that swim with me are English. No, that's not the way it works. Anyway, the dot product, which I believe was -1. So the answer would be C, as in Charlie's Cookies created crumbles. What? Yes. Charlie's cracked crumbly cookies created chaos because they were so good. Yeah, didn't something really bad come out? That's right. Oh. Yes. Question. Yes. Yeah, that's what Mary was just saying. I don't even have a cat, okay? So, although I went to mow my lawn last year, true story. Good thing I didn't just turn it on, because apparently a cat had gotten into our building where I keep my mower and had kittens, and apparently those 6 kittens were living underneath the well of my lawnmower. And right before I cranked the thing on, I hear a sound and see fur. I'm like, what is happening? And I go outside and there's like 6 kittens right near my blade. That could have been horrible. That would have been the most traumatizing moment of my life. It was so awful. Well, I did this stupid thing and told my wife about it. She loves cats, so she's like naming them all. I'm like, they're strays. Let them be. No. Well, good story. We started leaving food and drink for them in our building until they ran away. Although they could still be there. I have not been back in that building since last October. No, it is a jungle. I hate mowing. Anyway, we have too much to do, people. Phase shift. That's awful. What's happening? We're having too much fun here. Okay. Oh. Anyway, phase shift. Who remembers how to do this from like 20 minutes ago? C over B. What's my C? Negative. You always take the opposite. Over B. And remember, you know, if you always just remember that if you divide by a fraction, you're making it bigger. So basically just double this. But anyway, flip it, multiply. -2π/2. So which answer is it? B. Remember, it's not going to say negative. It's going to imply that with the left or right. So negative pi implies that it's going to the left. No, it's just, you could write it like that, sure. The reason it's not negative c over b is because in the original formula, it always had a minus sign right there. But essentially, yes, it's negative c over b, if that's the way you want to remember it. Yes. Wait, what? Pi over 4? No. It's dividing by 1/2, which is the same as multiplying by 2, so it's just pi.
So, what is b equals 1/2 x minus 2 pi?
Then it'd be positive pi over 2 over 1/2. Well, you said negative 1/2 x plus, then it'd be negative negative. So positive pi over 2, you take it divided by negative 1/2. Okay, last one. Basically, just do what it say. Subtract, find the mag. V minus u, negative 4 minus negative 2 is 2i, negative 2i. Negative 21 minus negative 7 is negative 14j. And then you just find the magnitude of that there, guy, by doing Pythagorean theorem. 4, 196, 200. Problem. The answer's not written like that. In fact, this question kind of ticks me off because they're like, ooh, we're fancy, we reduced it, but they didn't even reduce it fully. They look like idiots. The answer is C, because they halfway reduced it, which is just sloppy. So the easiest way to do this would be to just punch these in the calculator and see which one equals the radical 200 with a decimal. And the answer is C. It should be, yeah, 10 radical 2, but I bet they're Australian, writing their books. They're mad. That's right, they're taking it out on us. Are there any questions about any problems that we have worked?